Hello friends, myself Sanjay Kumar Adhikari again with second topic on this ATmega 328P. Today we will discuss about the peripherals, basic peripherals. We will start with GPIO and one thing I hope you are watching this with laptop or PC because mobile it will be difficult. And also once this video is uploaded I will provide that this blog link into that. If you look for the more information on the right side you will get that. Okay, so last time we discussed about the flow of bootloader, and from that bootloader we understood that how it jumps from bootloader to application and app start. So from that further flow application, what happens after 00? Okay, so what I did, one of that application dot assembly file asm file, which was method was discussed in earlier block, and based on that if I look into that, so 00 location we see simply jump command to this ba offset. It depends, offset may be different depending on that whatever the code, but anyway this goes to this C torrent, and this is that section, this particular section after certain commands related to some section copy and all that. So I'm not going to detail of that right now. Those are AVI related, application binary interface related things that we can see later in some other discussion. Right now the idea is that it jumped to that, and from there it jumped to the main of user application, not the main of bootloader. There was another main in bootloader. Okay, so this is the main of this particular application, and this you can find this particular file you can find inside the hardware Arduino, and this particular file you will find the main.cpp, and in this file it will do some initialization and then it calls setup. Some commands are there, then it calls setup, and it basically calling the setup defined in your sketch, and there is a for loop, and in that it is calling the loop which is in the sketch. So these two things, setup and loop, whenever you create any sketch you get these two things, correct? So those things being called from this particular function, invoked from this particular function. Apart from this, you say this is this if serial event run, then serial event run function it is calling. It means if this serial event run function is defined, then call that particular function. So this is a provision of a callback function. Normally if you see that sketch function, you generally see two things. Let's say this is I created some program, but by default whenever you create any sketch, so you do like file new or something like this, you get just setup and loop, correct? You don't have any idea that after the loop it will again call some other function, that is something called setup event, sorry, serial event. So this is some sort of callback kind of thing. So callback function, that when that this is something like in our kernel, any kind of kernel, these kind of stuff function will be there, so that will be calling some callback in the user application, and it's up to the user defined application. If they provide that particular function, that it will execute, so something like let's say creating process or whatever. So callback function, here if I look into that callback function definition, in the same file. So I see like serial event run, and if defined have this particular serial 0 interface, this should be there, and then if it is there, so this will be set, and based on the serial event, this is basically function. Okay, if this is there, this is defined in the user, then it will call this particular function. Okay, so the idea is that call back function will call this function provided you have defined it. So what is the benefit of this? The benefit of this, whenever any serial data come, you may utilize this function, or you may customize this for some other purpose also if you have defined this. So because if the serial is enabled, so you may use this particular function. So this is some sort of polling, correct? This is not a interrupt based here callback function. So what I did to further explain this, what I did, I have written only one particular function. This you should be able to see this void serial event, and in that I have put one print serial dot println my serial event, only one print function. And I can show you that in the setup I am not calling it, and in the main function loop function I am not calling it. Okay, so and also so not calling this particular function. Ideally, if we define any function we don't call, so there is no meaning of that to the linker. But in this particular case, this function is the callback function. So whenever we upload this, let's say I upload this particular function to my board. Okay, so what we will see there, that because this particular function is defined now, so I am expecting if I send something in that serial monitor, serial communication, even a single letter, so it should invoke this function, okay, and call this print. Okay. So this is what my expectation. Let's see how it goes, and it is uploading now, done uploading, fine. Now let's go to tools and serial monitor. This is that my default output expected. Let's no print right now for serial, so let's send one A or whatever, any letter I can send, let's say B or whatever, or maybe arbitrary B, any data, send. Oh, my serial event, keep coming, even if I clear it, will keep calling that particular function, because that data is still in the receive buffer of that serial. Okay. So this is what I wanted to show you about this particular thing. This is the callback function. Fine. Then after that, apart from that, last time we were discussing the program memory, and I would like to put again this particular memory map. And in the program memory, we found like we already verified application program memory and our bootloader program memory. Now after that we were discussing our this data memory. Data also we discussed that 32 registers, GPIO register. In that there were some indirect register like X, Y, Z. So others were normal registers, correct? So apart from that, we discussed last time like 64 IO registers from this. And also IO specific command, it was subtracting 20 hex from that. And extended IO we have not discussed so far. And next is internal SRAM, that is that our 2 kilobyte for starting from 100 hex to this. So this is available, but somewhere in the code we have to define this so that our linker knows that. So that actually we can define, there is a RAM start, RAM and function is there in IO, and it because it may vary also device to device. So there are different files these files, and there is another file io.h. So that io.h basically should include this particular file, and that is from this that common io.h include this based on this particular device. So this is device specific memory map file. Okay, now next question, how to customize that peripherals, because this is the device in discussion. So in that, if you note from the top 1 2 3 the pin numbers are there. So different pin, you see multiple things are, for example pin number 2 is mentioned like PD0, RxD, PCNT 16. So three things in the same pin. So this is actually most of the MCU processor you will find this particular thing. So one thing, whenever any silicon vendor sell a particular design a particular device, so like the same device will be used by multiple users for different purpose. Some user may require this PCI, some may require this UART, some may requare ADC, and one cannot provide all these features in all the pins together, because that will increase the size of the device and eventually the cost. Okay, but there is a way to do this thing. So that is called the multiplexing, pin multiplexing, and it is done in almost all that MCUs or processors, correct? And this normally this has to be done before reset, and some of the things maybe those are not dependent on power specific reset, some particular blocks, then those can be changed dynamically also, runtime also. In this case, in the schematic you will find RxD, TXD are connected to for that serial communication purpose. So definitely PD0, PD1 we cannot use for general purpose IO if we are using serial communication. So this is like that. If you are using a particular functionality, so that those pin will be occupied for that particular functionality, and some places these things will be automatically. Suppose if you select serial related block, UART block, then automatically that will override the GPIO functionality. Okay, so now this is each pin can be configured for particular functionality. So that is the pin multiplexing concept. This is the first point for any designer, and silicon vendors provide different utilities, tools to configure these permutation combinations. Because this is a small device, but for the complex device having number of pins more than 150, or it is very difficult to check all the permutation combination manually. Okay, let's see first our peripheral which we would like to discuss today, that is IO port. IO port you will find for each IO port, that is we call GPIO. So by default PB13 or some pin we use, I think that was a inbuilt, there was inbuilt LED connected to pin number 13 or somewhere, PB5 or that we need to check in the schematic. But the idea is that there is a PV port, there is a PC port, those kind of ports are there, and for each pin, let's say PV6, if we have to make this PV6 output, so we will have for each bit, we will have for each port, complete 8-bit port, we will have 3 registers. One is, and X is here like B, C, D, whatever, port B. And below second one, data direction DDR B. Okay, so pin B kind of. Okay, so here data register will be one. So one is, this is the important data direction register. Data direction register means if you put one corresponding to a bit, to that particular bit, it will become output. If you put 0, it will become input. That is, that it will set the direction, provided you are not using that particular pin for some other function. Okay, that is available for general purpose IO. And second is data register. Whatever data you put into that, that should go outside. So if port XN is written as 1 when pin is configured as input. Okay, so if suppose in normal case, if it is output, definitely whatever you write to that, if you write to 1, and it will go to logical level 5 board. If 5 board is the higher one, and if you put 0, that will go to 0, something like that. But if that is configured from here as 0 corresponding pin, and is basically corresponding pin number. For example, port X is B, port B 0. Suppose port B 0, so N will be 0. Or port B 5, so N will be 5 pin number. So here DDR B. So if bit corresponding to 5 is 0, means that is input. So in that particular case, if you write to the port, you write 1 there because that is input. So there is no meaning of writing to that. But what it makes, in case of input, it will make that as a pull-up register will be activated with that. To switch the, if you want to change that, then either you have to write to this 0 again, or you have to configure pin as a output. So input, if you want a pull up there by default, then you have to do this. Okay. And second thing, port input pin. So read only. So writing 1 will result a toggle in corresponding data register bit. So if you write 1, this is read only, but if you write to this a particular bit on this particular bit, or related to particular pin, then corresponding data register bit will toggle. Okay, so there is a pull up. Apart from these three, there is another register, pull up disable bit. So that is for all actually. So MCUCR register is there within that this bit. If you use that, then it will disable all the pull up function for all pins in all ports when set. So this is the global kind of pull up. Okay, so when that by default that port pin is basically after reset will be try state. Okay, so writing a 1 to the port toggles the value of that particular port accent, that is whatever our data independent of the value, whether it is a DDR whatever direction is set. So writing 1 to the pin 1, this particular input pin, if you write 1 to this, so whatever it doesn't matter what direction is there, so it will toggle there. So there is a instruction also for that SBI. Okay, so this was basically quick overview of my application program flow, and this callback function, and data RAM memory, internal RAM memory, and that pin multiplexing and IO port. Okay, so thanks for reading till end, and I am trying to improve the usability of this site. Please subscribe the YouTube channel Embedkari. Okay, thanks. Have a great time.